Question 1. This is a straightforward question, just like the ones we've done previously. It is a straightforward division. We have distance, 64.7, and time, 8.65. And we have an associated uncertainty. Because we need to divide, the first thing we need to do is the actual calculation. So first, please find the speed. This should give you a value of 7.48. Then deal with the uncertainties. Because it's a division, the fractional uncertainty is equal to the uncertainty in the distance plus the uncertainty in the time. Completing for these values, the uncertainty in distance over the distance plus the uncertainty in time over the time equals the uncertainty, the fractional uncertainty in the speed. So that gives you a fractional uncertainty, which you then need to multiply by the value 7.48. That will give you an uncertainty of 0.1. It's possible that you got this bit wrong. Be careful with Kognity. They're very specific about the number of significant figures you need. This question is either a power or you can treat it as a simple multiplication. A water tank is in the shape of a cube. What is the absolute uncertainty in the volume of a tank? You can either treat it as a multiplication, which would be length of side, 3 meters, times length of side, times length of side, or you can treat it as a cube calculation. Volume equals the length cubed. Step 1. Find the volume. If the length is 3 meters, now calculate the volume so you have that value. Now the rule is that when you are multiplying uncertainties, percentage uncertainties are added. In the same way that you are adding fractional uncertainties, if you have a percentage uncertainty, you add the percentage uncertainty. So you end up with an uncertainty of 3%. Okay, that's the total percentage uncertainty for volume. Now, you can either work out, using your calculator, 3% of 27, or you can unpack the percentage 3 over 100 times 27. This is the last part where you end up with your final absolute uncertainty. You go from percentage to absolute by multiplying the percentage either as a percentage using your calculator or as a fraction of 100, 3 over 100. Please ask for help if you're still not sure how to do this question. Question 3. This is now getting a little challenging. A pyramid has a square base of side x and height h. The volume of the pyramid is given by the expression v equals x squared h over 3. If v is measured to 5% and h is measured to 3%, what is the percentage uncertainty in x? Percentage uncertainty. So we need to end up with the total percentage uncertainty. Now, what are our rules? When we are multiplying, we add percentage uncertainties. When we are dividing, we are adding percentage uncertainties. And when we have something to a power, we just multiply the percentage by that power. Okay? So step 1. The first thing you have to do is to rearrange the equation to make x the subject. So we need to place it in the form x equals. And this is what it looks like. X equals square root of 3 v over h. Now let's have a look at our percentage uncertainties. V has a percentage uncertainty of 5 and h has a percentage uncertainty of 3. So the total percentage uncertainty of 3v over h is 8 because we're adding the percentage uncertainty of v plus h. Now, this part of the equation is to the power of a half, right? That's what the square root means, to the power of a half. So basically, the percentage uncertainty here, which is 8, you now need to multiply by the power, which is a half, right? Therefore, you end up with 0.5 plus 8 equals 4%. Now, a lot of people got this question wrong. The length of the pencil is measured using part of a meter rule that is graduated in millimeters. Here we have a pencil, and the measure goes from 16 approximately to 22 approximately, or 21, sorry, 21. Now the uncertainty is plus or minus 0.05 because it's an analog instrument. But what we're doing is we're carrying out a subtraction. The length of the pencil is 22 plus or minus 0.05 minus 16 plus or minus 0.05. So therefore, the actual answer would be 22 minus 16, which gives us, 22 minus 16 will give us 6 plus or minus 0.1. Why 0.01? Because when we are subtracting a value, we add the absolute uncertainties. So the uncertainty would be 0.05 plus 0.05, which gives us 0.1. Question 5. The volume V of a cone of height h and radius r is given by the expression V equals pi r squared h over r. In a particular experiment, here is a 5 ohm uncertainty in V. There is a 5 ohm, what are we talking about? 5% uncertainty in V and 2% uncertainty in R. What is the percentage uncertainty in H? Step 1. Rearrange the equation to make H the subject. So if we move down, H equals 3V over pi r squared. If the uncertainty, the percentage uncertainty in V is 5 and the percentage uncertainty in R is 2, then what we need to do here is first find the percentage uncertainty in R squared. The percentage uncertainty in R squared would be 2, because it's a power, times 2, which gives us 4%, right? That's 4%. Our percentage uncertainty in V is 5%. So in total, 5 plus r squared gives us 9. Similar question, question 6. The period t of oscillation of a pendulum of length L is given by t equals 2 pi square root L over G. If the uncertainty in G is 2% and the uncertainty in L is 6%, what is the uncertainty in, or the percentage uncertainty in T? I'm hoping that by now you're more comfortable with this kind of question. So stop it and try it again. See if you get the right answer. The correct answer was 4%. Let's go through it. If the percentage uncertainty in L is 6 and G is 2, we are dividing these two quantities. So what we need to do is add their percentage uncertainties. So we add 6 plus 2 to give us 8. But L over G is to the power of a half. So 8, which is the percentage uncertainty here, times a half gives us 4. So you multiply by the power. This question, question 7, is very similar to the volume question. We have the lengths of the sides of a room, 10 times 4 times 3, each with an uncertainty of 10%. What is the absolute uncertainty in the volume of the room? Step 1, find the volume. The volume would be 10 times 4 times 3. 10 times 4 times 3 will give you 120 meters cubed. Now, what is the percentage uncertainty in this volume? Well, 10% plus 10% plus 10. That gives us 30%. So 30%, how do we find 30% of 120? Well, you can either set your calculator, 30, the percent button, times 120, that will give you your answer, or you express 30 as a fraction. 30 divided by 100 times 120, and that gives you 36. Careful though, because it says give your answers to one significant figure, 1. So that rounds up to 40. This question is about instruments. The potential difference across a resistor is measured with a digital voltmeter. That means that the uncertainty is plus or minus the smallest interval. So it would be plus or minus 0.01, right? I know I made a little mistake there. So the uncertainty here would be 0.01. So if we work that out as a fractional uncertainty, it would be 0.01 divided by 0.10, okay, which gives you a percentage uncertainty of 10%. Now, what happens when we square it? Well, whatever we find, whatever we have as our percentage uncertainty in V, we now need to multiply by 2. So it would be 2 times 10, which gives us 20%. And I think that's it. We'll go straight to question 11. Question 11 asks you to do a number of different calculations. Basically, you have to perform all the calculations given. The student measures two lengths, A and B. Which of the following quantities has the largest percentage uncertainty? So you need to work out all four choices. B minus A, B, which is quite straightforward, and A plus B. B minus A would simply be 20 minus 10 plus or minus 0.2. Work that out as a percentage uncertainty. And then do the same with A plus B, which would be 30, 20 plus 10, plus or minus 0.2. As you can see, as a percentage uncertainty, B minus A is much larger. And that's it.